Hello everyone. So in today's class we will learn cutting of lens. Okay, means if we will cut the lens and we will place in some manner, then how the focal length is going to change, as well as power that we are going to learn in this topic, cutting of lens. So let's start. This is the first case. Now we are having lens like this. Okay, and this lens we have cut like this, and now these two parts we have placed like this. This dotted line is what indicates that we have cut this lens like this, and now these two parts we have placed in this manner. Then in this case, for this also focal length will be f, and for this also it will be f, because r1 and r2 will remain same. R1 and this one is r2. Here also this is r1 and this one is r2. So r1 and r2 will going to be remain same, and therefore in this case intensity of image will decrease. So intensity decreases, whereas focal length remains same. Why? Because R1 and R2 is going to be same, and therefore R1 and R2 remains constant. Okay, right. Next one. In the second case, what I am doing now, let us suppose lens is like this, and we cut vertically. You can see this line, this is the line, and like this I am going to cut now this lens. Like this we cut this lens, and now these two parts we have placed like this. Okay, like this we have placed now this lens after cutting. Now here, this is lens 1, this one is lens 2. And now here this lens will have focal length f1, this will have focal length f2, but as these two are equal, so this is also having focal length how much? Same, that is f1 only, right? So here it is f1. Now if I want resultant focal length, that is 1 by f is equal to 1 by f1 plus 1 by f1 only, because f2 is going to be f1. So this is 1 by f is equal to 2 by f1, and therefore f1 is going to be 2 times of first one. This is your f focal length. Okay, this is f. Or this is just resultant focal length. Don't keep anything here. So here what happens for this first part? Focal length is getting doubled. Focal length doubled. Next, now see this arrangement. If we have placed lenses like this, what will be their focal length? You just see how I am placing the lens. Or this plus this, or this plus this. Either you keep anything out of these three combination. 1 by f net will be 1 by 2f plus 1 by 2f, which is equal to 2 by 2f, and therefore f net is equal to f, and therefore power net power is what? Just reciprocal of focal length in this case of combination. Anyone out of these three. Okay, right? Next one. Next, fourth case. Now let's keep lens like this. Like this we have placed. Then in this case, as you know, this is focal length f, this is focal length f, and then 1 by f net is equal to 1 by f plus 1 by f, which is equal to 2 by f. So therefore, f net is equal to f by 2. Yes or not? This is 2 by f. So if we will take reciprocal, this is f by 2, and therefore if I want power, power is equal to 1 by f net. So this will become same like this, that is 2 by f, right? So for this combination, this is what power and focal length is. Next one, if we will keep one reverse and one like this, then what is the focal length? Let's see. Here only I am giving. Suppose now we kept one lens like this and another lens. If we keep like this, then for this focal length is positive and for this focal length is negative. So if I want 1 by f net in this case, then you will get 1 by f plus 1 by minus f, which is equal to 0, and therefore f net is going to be infinity, because this is 1 by f net is 0, so f net is equal to infinity, and power p is equal to 0. Keep it in mind. Okay. And power p is, you can say here, right? If we will keep like this combination, then we will get like this focal length, right? Next. Now, next one, this is fifth one finished now. Now, sixth case. Suppose two thin lenses. If two thin lens are placed or separated, placed the distance apart. Distance d apart. Distance d apart. Then what is the condition? So how you are getting this diagram? This is the one lens. Here is another lens. Okay. This is principal axis. And now this distance is how much? D. They are separated by distance D. Okay. And it is having focal length f1. This is having focal length f2. Then if you want to find resultant focal length in this case, then 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 into f2. So that is your, if you want p net in this case, p1 plus p2 minus d into p1 p2, because 1 by f1 is p1, 1 by f2 is p2, and 1 by f1 into 1 by f2 means same p1 into p2, right? Okay, next. Suppose now we have two lenses like this placed. I am showing you the diagram. Something like this. So for this part you are having refractive index mu c, and for this part you are having refractive index mu d. Okay. Then in this case, how to find out the focal length for C part? So here 1 by Fc is equal to mu C minus 1 by using Lensmaker's formula only. So 1 by infinity minus 1 by minus R. Why? Because for this is R1 is equal to infinity, and here R2 is equal to minus R. Okay. So therefore here 1 by Fc is going to be mu C minus 1 into 1 by R. Call this equation number 1. Next, for this D part, 1 by Fd is equal to mu D minus 1 into bracket minus 1 by r minus 1 by infinity, because for this already it is minus r and for this again it is infinity. So therefore this one, and therefore 1 by ft is equal to mu d minus 1 into bracket minus 1 by r. So this is what your equation number 2. So if I want power, so 1 by f net is equal to 1 by fc plus 1 by fd, which is equal to p net, and that is equal to r by mu c minus mu d, mu c minus mu d. If we will do this from equation 1 and 2, we will get the same answer. Okay, if like this is there, you can use this formula. Note down. Okay, next. Now, in the seventh case, what I am doing, you see, or eighth case, this is it eighth case? Okay, eighth case. In this eighth case, what I am going to do, see now. Okay, so something like this. And now this one is R2, this one is R1, and here it is R1 dash, and this is R2 dash for this surface. and this is liquid, so this is the refractive index of liquid is mu n. Can you see it clearly or no? This black one you can see very nicely. Mu of liquid, right? Mu of liquid, this is. In this case, 1 by F is equal to 1 by F1 plus 1 by F of liquid plus 1 by again F2 for this. So if we will use the lens maker's formula for 1 by FL, we will get mu1 minus 1 into 1 by R1 plus 1 by R2. Next is 1 by FL. This is 1, okay, not liquid. This is for first surface. So I'm keeping here first. And this is for liquid. Then this is mu of liquid minus 1 into 1 by R2 plus 1 by R1 dash. 1 by R2 plus 1 by R1 dash. Next is again for 1 by F2. That is for second refractive indices of this medium. This is mu2 minus 1 into 1 by R1 dash plus 1 by R2 dash. So if you want resultant power, that is equal to your P net. So if you will calculate this all, you will get the same thing. Right? Understood? So note down. And next one, that is rotation of lens. Rotation of lens. Now before we was having like this lens, and this is the principal axis, but now we have rotated. So how we did now? Now we rotate it like this. Like this. Now this is your principal axis, and this one is your old principal axis. So whatever this angle is there, that is what angle of rotation, that is theta, with which we have rotated this lens. Then what we will do, all calculation with respect to new sign conventions. This is your principal axis, and all calculations considering new principal axis. Okay, so this is what rotation of lens. So in this total class we have learned cutting of lenses and different refractive indices, then how to use lens makers formula and how to solve problems. You just go through it, and then tomorrow we will start either defects of vision or optical instruments, right? Okay, let's stop here for today. Bye.